Carstairs Junction, Scotland. A bit of a backwater, to judge by the signal box, some might say. But they'd be wrong, for this junction is vital. It lies on the West Coast main line linking London and Glasgow. It's part of a mammoth project to re-signal all the way from Glasgow, over the rugged rolling country to the south, and on through industrial Britain to a point near Warrington, there to join the already modernised route to London. Designing, building and installing all the equipment which will replace many hundreds of boxes like this one will take over 3 years to carry out. In the drawing offices, the 2 years of preparatory work is in full swing. The planning and designing of every function the 5 boxes will perform in their control areas. The main scheme plan has already been drawn up. It's the key to the whole project, for from it springs all the complex stages of preparation. The main specification, signal sighting programs, cable route planning, and later the voluminous control tables. These designate the functions of every one of the hundreds of points and signals. From these tables, the wiring diagrams are drawn up, and then begins the long, intricate process of checking and rechecking. In parallel with all this, production can begin in the factories, and the sooner the better, for the shopping list is a long one. Item, 1,600 signal heads, intricately assembled, lined up and tested. Over 1,000 point machines, both cog and belt driven, all proven and perfect. Over 60,000 relays and relay units. Now the signal relay is the key to safety on the railway, and because it must always fail safe, its design and performance has to be to an extremely exacting standard. For example, contacts are cleansed in an ultrasonic bath of arcone P and dried in thermostatic vacuum ovens. The contacts are silver to silver impregnated graphite to avoid any possibility of contacts welding together in service. To ensure that the armature immediately drops away if current fails or is switched off, the cores are of a particular iron which retains no magnetism. As time goes on, manufacture and installation will go forward together, production building up just ahead of demand on the site, as we shall see as we move between factory and track. In fact, a great deal is already happening out on the track. Cable laying, for instance, had been in full swing for some time. Several cables can be laid at the same time. Power, signal and telecom cables carried on different drums on the same train. The work continues through the season, every kind of weather having to be faced to keep up with strict schedules. Armoured cables are often used where they have to leave the troughing and are exposed to arduous conditions. All the cables are cut to length at the factory and wind off the drums right up to a location, with a foot or two for termination, of course. Here at Motherwell, the box has had to be built on top of an embankment. In spite of the clever equipment around today, the wit and adaptability of the human machine is clearly best when faced with a job like this. On the other hand, the manufacture of cable is very skillfully carried out by machines. This is going to finish up as signal cable. The copper is first drawn down in several stages to the specified gauge. Then it remains in vacuum annealing ovens for 24 hours before receiving its coat of tin. The cores are numbered 1 to 12, or whatever numbers are to form the finished cable, so that each can be identified in use. Insulation is of high-grade rubber sheathed with polychloroprene. Here, 12 cores are being laid up, brought together through a die and wrapped with plastic tape. This is then fed into the vulcanizing tower, where a rubber extruded sheath is applied, and this is vulcanized under pressure in steam-filled tubes housed in this tower structure. This is power cable, 4-core, solid aluminium, PVC insulated. The single cores are fed through the PVC plant, which provides the individual insulation. The drum twister laying up machine is charged with 4 drums of these single cores. They're fed through a die and twisted by rotation of the haul-off drum. By careful control, the 4 sector-shaped cores are made to sit together to form the circular section within the die. They're then bound together with transparent tape. By now, a variety of other jobs were going ahead all over the railway, carried out over and under and between trains. Although work might seem haphazard, it was in fact tied to very detailed plans. When the engineers had track possession for one job like this, it meant that others could install point machines or sight signals unmolested by passing trains. All the work involved in designing and building this control panel had to be planned so that it was ready for delivery on a specific date. This is part of the Warrington panel, the first of the 5. Meanwhile, back at the factories, the production lines have been carefully scheduled to match the increasing demand from the sites. These are plug-in geographical units, so called because the geography of the circuits directly relates to the layout of the functions they control on the ground. These frames are designed to guide the operators as they route the wires in a variety of patterns. A small tape-controlled device indicates a routing code for the girls to follow. The circuitry of these cards is photo-etched onto the base, ready for the various components to be fitted and wired. After inspection, they run over flux and solder waves, which solder the component wiring into the printed circuit. The temperature is very accurately controlled to produce good joints without damaging the minute components. The finished cards themselves become sub-assemblies for the next stage, in this case, chain describer equipment. Equally fascinating is the production of signalman's control panels. These are made up of mosaic or domino units, small assemblies which control and display conditions on the track over which the panel operates, the whole forming a mimic diagram of the area. A range of individual units provides displays, push buttons, rotary switches, and so on. The front tiles are either stenciled or etched with the legend which relates to the function of the equipment to be fitted behind it. The whole panel is patiently built up, mosaic by mosaic, on the framework, and all the pre-wiring carried out and tested in the factory. Here in the Motherwell box, part of the control panel has already arrived from the factory. This box will operate points and signals over the long, lonely track running south to the English border. Systems of remote control use either time or frequency division multiplex techniques, depending on the amount of information which has to pass. They extend the arm of the signalman by allowing many controls or indications to pass along single pairs of wires. Time division multiplex is generally used to link remote but large control areas and employs an electronic scanning system which identifies the code of input messages, verifies and acknowledges them, and routes them to their right destination, where they carry out their many functions. The FDM system usually caters for individual functions along the way, and one type uses sets of mechanically tuned vibrating reeds, oscillating to exact frequencies to identify and transmit information. Highly selective receivers respond only to the matched frequency, identifying the message and then allowing it to be accepted. Extremely careful tuning of the reeds is fundamental to the accuracy of the system. Equipment is housed in newly built location cupboards and relay rooms along the way. Our old friend Carstairs Junction will have its own new equipment, and so the old box won't be wanted anymore. There's another interesting feature of the area between Motherwell and the border. As an interim measure, local control systems, using much of the new equipment in nearby relay rooms, were set up in some of the old boxes. Ready over a year before the completion date of the main scheme, this enabled these areas to be commissioned and come into service on their own. In contrast, work is progressing fast on a rather larger installation at Preston, one of the 3 boxes in the north of England. Instead of a panel 6 feet long, this one is nearer 75 feet long. Below stairs in the relay rooms, a mass of connections which could not be pre-wired in the factory have to be wired up here. The possibility of error would seem formidable, but the principle of prefabricating and testing so much of the circuitry in the factory greatly reduces the likelihood of a mistake here. Standard plug boards fit the framing into which a variety of pre-wired and tested units can be plugged. Here's a geographical unit finding its proper place. Upstairs, cable connections between control panel and relay rooms are laid out ready to be plugged in. A 180 miles to the north, in the huge Glasgow central box, a unique technical situation had arisen. New in 1960, it now has to take on still further responsibilities, which means a lot of fresh equipment, including a new control panel. In order that two groups of specialists could work without disturbing each other, part of the control floor had to be partitioned off, leaving the signalman on one side still running the railway with the old equipment, and the technicians on the other installing the new.
Ian Richards.
Routes set up on the old panel now show up on the new one too. That is one of the miniature cathode ray tubes which display train numbers. As a train passes, its progress is simulated by the number, which jumps from window to window across the diagram. But now, train description is computer-based. Here the equipment is on test at the works before being sent to the site. The computer which controls the system carries both the main program and many subroutines, each of which has a particular function, such as to display a number, clear it, transmit it to another box. Automatic train reporting is an extra facility which this equipment can provide. Use is made of the train information present in the system and its relationship to timed train movements past key points. The system extracts and selects information as to position and speed, and forms it into messages which are passed to operators in such a way that each receives only information useful to him. This is in the form of a printout by electronic thermal printers linked to the computer. Information on demand is available to operators by keying simple codes on their teleprinters. Every function of the TD system has to be proven as simulated trains pass over one route after another. Their progress checked visually and monitored electronically. As the Scottish contract neared completion, it was time to remove the local display panels from the old boxes south of Motherwell and make reconnections, so that the Motherwell power box would take over control of the area. The funereal aspect of the procession is a little inverted, for in truth the contents of the coffin are very much alive, whereas it's the mausoleum it came from which is doomed. In the relay room, final reconnections to Motherwell are made, and then the technicians move on to other areas. Finally, with the master switch setting on the Carstairs panel turned from local to master control, the last of the relay rooms along the Scottish section comes under the umbrella of Motherwell. But the equipment must still be tested. On site, a loco is run through the area, aspects set, reset, and checked with control.
$6.13. Aye, it's okay. It's okay.
The commissioning of a power box is a much more complex affair. This is one of the major weekends at Carlisle. Once upon a time, the commissioning of boxes was a hectic affair. Nowadays, the pre-wiring and testing of groups of components in the workshop has removed much of the cliff-hanging atmosphere of old.
Existing 214 track. I'll tell you, if you have a look at the panel in the Carlisle 3 signal box, that'll show you where the joint is for 214 track. 214 and 215.
Right, Brian. This is going on right there, yeah.
Mind you, that's cutting, it's not adjusting. Now, that's on the back. Go on, look it right back. And back. Down. And back. Right. Run them normal. Right. And we've got left hand switch closed now. Over. 788. It's okay. Yeah. We've got one switch now. Yeah.
Look at that. Right, watch your fingers.
Yeah. Let's have a go then at sheets 19 and 20.
Single ended. Yes. Right, which switch is made up? The left hand switch closed, correct. Give me 2 brakes, please.
What? 688s?
Yeah, the North East area.
No, well,
No, I've tried it. No point in it. You know,
no. What's he worried about? We've got full control of them.
Right!
Okay. Oh, champion. Champion.
Track full sped now then, so you should be okay now. How do they lie now, mate? Right hand switch both ends.
Right hand and right. One, two,
As daylight and the first morning trains crept towards Carlisle, the job drew to an end. By dint of a lot of hard work and not a little caring, everything seemed to work. And why shouldn't it, complicated as it was? And so the objective was achieved. The re-signalling of 1,000 track miles, used by many hundreds of trains every day, all controlled from just 5 boxes. Inside a completed box, a route is set, sending out impulses to points and signals over great distances. In split seconds, equipment in the relay room checks conditions on the track before setting the route and signalling the train.